Holiday and Resnick, Chapter 5, Problem 43. A chain consisting of 5 links, each of mass 0.10 kilogram, is lifted vertically with constant acceleration of magnitude 2.50 meters per second square. Find the magnitude of A, the force on link 1 from 2, the force on link 2 from link 3, the force on link 3 from link 4, and D, the force on link 4 from link 5. Then find the magnitude of E, the force on the top link from the person lifting the chain, and F, the net force accelerating each link. Okay, link 1, 2. We know that gravity, mg, and it's being pulled up 2.50 meters per second square. So what we have is F 2 to 1 minus mg is equal to ma. So F 2 is equal to mg plus ma. F 2 is equal to m, which is 0.1, times 9.8 plus 2.5, and that's going to equal 1.23 newtons. Now we're going to look at the force F3(2) have, and what we'll have is F3(2) at this point minus how much weight is going down. We got each one of these weigh 0.1 kilograms, and we have 2 of them hanging down. So 0.1 kg times 2 is equal to ma. So F3(2) is equal to 0.1 kg times 2, the 2 links hanging below 3, plus the total mass. This M is the total mass, which is 0.2 kg times 2.5. That's the acceleration, and that's going to equal 2.46 newtons. I had to go back and put my 9.8 meters per second square in, and it ends up being 2.46 newtons. So we go up to F4(3). So F4(3), this chain link here, minus M, which is 0.3 kilograms times gravity, 9.8, which equals M, which is the total mass up under there, which is still 0.3 times the acceleration of 2.50. So F43 is going to equal 0.3 kilograms times 9.8 plus 0.3 kilograms times 2.5, the acceleration upward, and that's going to equal 3.69. This is C. And this one here is B. And this is A, question A. So now we want 5.4. So that'll be D. We know what to do now. We're going to take F5.4, that's what we want. And how many links we have up under there? They each weigh the same. 1, 2, 3, 4. So that's minus 0.4 kilograms, that's the weight, that's gravity pointing down, times 9.8 is equal M. M on the right side is always the total mass, which will be 0.4 again, times its acceleration upward, which is 2.5. So F5.4 is going to equal 4.4 times 9.8 plus 0.4 times 2.5, and that's going to equal 4.92 newtons. That's D. So now we want to figure out E, which is asking the force F on the top link from the person. Well, it's the same thing. Nothing really changed. And remember, this is problem the same as problem 13 that we worked. The only difference is that in problem 13, they gave us newtons, the force, the weight, and then we converted that to mass, to kilograms, and it's the same as that problem with different numbers. So E, let's say F person with length 5. Okay, we got a rope around there, and he's got his hand pulling this. F person minus, well, how many links we have up under there? 1, 2, 3, 4, 5. So that'll be 0.5. That's the M for my pointing in this direction, times G, which is 9.8, equals the mass of all 5 of them is 0.5, times the acceleration upwards, which is 2.5 meters per second squared. So F person with length 5 is going to equal 0.5 times 2.5 plus, well, this goes on the other side of the equation, 0.5 times 9.8, and that's going to equal, that'll be 6.15 newtons for E, and let's see what F want. The net force accelerating each length. Well, I would say a gimme. they're saying. So force is equal to mass times acceleration. And we just want each link. So each link is 0.1 kilograms times the acceleration 2.5, and that's going to equal 0.25 newtons. We just started from the bottom link and worked our way up, realizing that each link that we go up have the weight of the loops or links of chain beneath it that we would add in the minus mg direction.